Hello, everyone. In this video, we start our work in section 5.4 on integration by parts. So now we learn about our second method for computing more complicated integrals. So in order to motivate this new method, let's recall some differentiation properties. So recall the product rule for differentiating. So we have something like a function u times v, and we need to take the derivative of this product. Then how we do that is we take the first function, so u of x, and then the derivative of the second function plus the second function times the derivative of the first function. So what does this mean? This means that the derivative of this function here is equal to this function, which means, recall, if we go derivative this way, then this way is the antiderivative, which means rather than writing a dx, or the derivative of this is equal to this, we could say the integral of this is equal to this function. So let me write that out a little bit more cleanly. So again, I can go derivative and get here, or I can take integral and get here. Okay, so that means then that, let's write this out. That means u of x times v of x is equal to the integral of u of x, v prime of x, plus v of x, u prime of x. So cleaning this up a little more. Okay. Great. So now rather than writing primes here, I could spell this out a little bit more and say dv dx, because I'm taking the derivative of v with respect to x, but we'll just leave it as such for now. Okay, so an integral of a sum would be equal to the sum of the integrals. So I could bring that integral into each term. So if I do want to simplify things a little bit, I could just call this function u, this function v, and then I can write here that u times dv, and for this function, I can write v du. So this is just a little notation game here. But what this means is that my function u times v is equivalent to the integral of u dv plus the integral of v du. So let's carry out one more algebraic step here. I'm going to solve for the integral of u dv. So that means I'm just going to subtract this integral over to the other side. So I'm going to start with my highlighted integral. So I'm going to start with the integral of u dv is then equal to u times v minus the integral of v du. So what I have just derived or computed is the integration by parts formula. So I'm going to write that out. This is the integration by parts formula. So we're going to come back to this. You're going to come back to this when you do more examples. So I want us to think of this original function, integral of u dv. That's like our starting integral. So if we're given an integral and we're able to identify parts in it as a u and a dv, then we can solve the integral another way by looking at u times v and subtracting the integral v du. The reason why we do this right-hand side, you might be thinking, looks a little more complicated than this. So what's up? Well, the reason is because sometimes this u dv integral is going to be more complicated than the v du integral, which we'll see in example 1. So without further ado, let's move down to example 1. We're going to evaluate the integral of x cosine x dx. So we see this isn't really a straightforward integral. If we use a u substitution for like cosine x, and we just get a sine x. And using a u sub for x does nothing. It just rewrites everything with u's instead of x's. So as is, nothing works for us. But what if we try to identify a u and a dv? So I'm going to let x be u and let cosine x dx be dv. So I'm going to write those down. So when I do integration by parts, I like to set up a little table for myself. So I do u here and I do dv down here. So u, I'm going to let u equal x, and dv, I'm going to substitute cosine x dx. And the reason why I do it like this is because when we are going to use this integration by parts, I need a v and a du. So I need the antiderivative of dv, and I need a derivative of u. So let's do the derivative first. Derivative of x is just dx. And then the antiderivative of dv is going to be sine of x. Recall derivative of sine is just cosine. Okay, so we have sort of our basic substitution setup. So what the integration by parts formula says, so I'll say integration BP, integration by parts, says that the integral of u dv is equal to the integral of u times v minus the integral of v du. So for us, using this information here, this becomes u times v, which is up here. So that would be x times sine of x minus the integral of v du. So that would be sine of x dx. And as we see, the integral that comes out is just the integral of sine of x, which is a lot more simple than integral of x cosine x. So let's carry this one step further. So this just becomes x times sine of x. Then we have the antiderivative for sine of x. Well, antiderivative of sine of x is negative cosine of x plus c. All right, so let's clean this up a little bit. These two negatives cancel out to just become a positive. So we have x sine of x plus cosine of x plus c. So we've computed the integral. Awesome work. Okay, similar to the integration by substitution, integration by parts becomes a lot more simpler, a lot more clear the more problems that you do. So keep up the hard work.